Well, good evening, everybody. Tonight's webinar is the number 8 in the series for this Deep Reinforcement Learning Nano Degree course. And tonight's webinar is about the navigation project, the first real project for the course. So I'm going to talk tonight about how you can achieve success in this project. So with that, let's pull up the slides and we'll get started. Okay, so as I said, this is the 8th webinar in the series, and it's the navigation project, how to achieve success. So the objectives this evening are first to just introduce the navigation project, describe what it's about, and provide some hints on some ways to modify a previous project that you've worked on in the course to work with this project. And then the second half of the talk this evening is going to really be about what you need to do when you submit the project, because just getting the agent to learn the environment and learn how to navigate the environment and collect the bananas that are the part of this particular exercise. Second half of the whole project is really to describe the project in a README file and to prepare a report. And I can tell you from grading many of these projects that almost everybody gets the project part of it right, as far as the code and getting their agent to solve the environment. But quite a few get rejected for not including all the things that the rubric requires in the README and the report. So we'll talk about some of those common issues here this evening also. So let's start with the navigation project itself. This one is the simplest of the 3 projects in a way, but also in a way it's the most difficult because it's your first experience of really integrating an agent with this machine learning environment from Udacity, from the Udacity provided from the machine learning agents Unity engine. And that engine's a little bit different than the OpenAI Gym engine that you're familiar with in the other mini projects. So I think the 2 difficult parts of this are to get the interface right to work with that new environment. If you decide to run this environment on your own personal computer instead of using the workspace, then there's some challenges there sometimes. So it's worth exploring that avenue, though, because if you ever do any real work on outside of the course, you're going to have to be able to build a system on whatever computer you're working with. So it's a good exercise to do that on your own system. But of course, using the Udacity workspace is also perfectly acceptable. So the navigation project, it's in essence, you have this square world. It's pretty large, and it has a bunch of bananas in it. Some are yellow and some are blue. And your agent has to learn how to navigate around this environment and run over or pick up the yellow bananas while avoiding the blue bananas. And every time you pick one of the bananas up, it gets dropped someplace else in the environment. So you can essentially have your agent continually wander around in this environment looking for these yellow bananas. The reward the environment will give you every time that you run across a yellow banana is +1. If you happen to hit a blue banana instead, you get -1 reward for that. And to achieve success, to solve the environment, you have to score an average of 13 bananas per episode. So that means you need to collect 13 more yellow bananas than you do blue bananas over each episode, averaged over the previous 100 episodes. So it's a bit of a challenge, but it's certainly achievable. And by starting with the Lunar Lander mini project code base, you can make a few tweaks to that code base, and once you've interfaced it to the ML agents environment and the bananas environment that you're given from Udacity, then you should have no serious problems with it. But let's talk about some hints on achieving success. So as I said, if you go back to the mini project on the Lunar Lander and take a look at that project, it was in the value network lesson. You'll be able to see a code base there that'll work very well for this environment. It's a DQN code base, and there's basically 3 files here that you need to be concerned with. The first one is the main file. It's the Jupyter notebook, and it sort of sets up the environment, interfaces to the environment. loops through the episodes and has your agent do all of the things each episode to collect reward and transition between states and all the typical things you need to do in a deep reinforcement learning project. Then the other two files are helper files. There's a model.py file that has the neural network. It's the DQN network model that's used to evaluate the Q value for your network. So you can take a look at that. The same or similar model file is useful in this navigation project. And then the other main file is DQN agent, and that one has all of the code in it for actually doing all the things that an agent would have to do. Things like taking actions, learning, adding the experience replay buffer and manipulating that buffer. All the things that the agent has to do are encapsulated in that DQN agent class, and your Jupyter notebook will instantiate a member of that class as your agent, and then make calls on that agent library to perform all the actions that you typically need to perform. So if you understood how the lunar lander worked, again, the trick on this is to make the interface work to the ML agents library instead of the OpenAI Gym library. And that Unity library is a little bit different than OpenAI Gym, but it's pretty similar. You have the similar kinds of almost every one of these environments that you work with. They have a similar set of actions to perform to set up an interface. And if you look at what Udacity has provided in the first couple cells of the notebook, there's a cell on examining the state and action spaces and taking random actions. If you take a look at those, you can get some good ideas on how to interface to this environment. The last point on the slide for the hints is it's probably easiest to start with the Udacity workspace. I'd recommend not using the GPU. In general, I think you're given about 50 hours of GPU time. This particular problem can be solved actually without any GPU at all. So it might be better to save the GPU if you're going to continue using the workspace for the later projects, especially the last one. This first project on navigation, you should expect to take 300, 400 episodes is a pretty average number of episodes to solve the environment. If you're not making a lot of good progress by the 300th episode, I would suggest stopping and taking a look at your hyperparameters or your model and make some tweaks to it and try again. You don't need to let it run for thousands of episodes. You really should be able to make good progress in a few hundred, certainly less than 500. The last project I might mention is typical to take 2,000 or 3,000 or more episodes to solve that problem. It's a much more difficult problem. So saving your GPU resources, your GPU time for that particular exercise is probably something you might think about. Also, the last option here is to rehost this whole environment onto your local computer. There's a topic 4 in the project that talks about how to do that for Mac or Linux or a Windows environment. I've done something similar on Linux and Windows, and it's fairly straightforward if you follow the instructions. The main thing is to make sure that wherever you happen to put the ML Agents library and the Bananas app that you get, make sure that you have the right folders linked in to point to those directories. That's probably the most common error that you have to overcome when you're rehosting this. But otherwise, following those instructions, they're very straightforward, clear-cut, and you should be able to do that. As I said, it's worthwhile doing that. Sometimes the Udacity environment can be a little finicky, and you need to start the kernel with every episode or every run-through. Not every episode, but every run-through. So if you have it on your own computer, you have more control over those sorts of things, and you probably can make more rapid progress with the project on a local environment once you get the initial things set up. And again, once you set it up locally, if you do that on this first project, that same setup can be easily tweaked for the other two projects as well. So I would recommend you try that. There's a lot of good learning, and if you ever do something in a real project outside of Udacity, you certainly will have to be able to do that. So it's a good experience. So a little bit of advice. I would first, as I said, start with the Lunar Lander code. Go through those files, the model.py and the DQN agent.py. If you didn't really study them during the Lunar Lander mini project, be sure you go through them now and understand everything that goes on in those two files. There's the model.py files. It's fairly straightforward. It's very simple, so that should be fairly easy to understand. The agent file, there's some things in there that if you hadn't gone through and learned how it takes all the actions and how it implements the epsilon greedy mechanisms and how it works with the soft update process and how the learning in particular works. It's worthwhile to go through and study that code and understand it. If you understand that code, then it's much easier if you're making changes to try to manipulate your baseline in order to make progress in this. And you will have to make some changes to both of those files, actually. Perhaps not model.py, but certainly DQ and agent. There's a few tweaks you're going to need to make in there. So understanding it before you start changing it is good advice. The other thing that is new is the existing baseline for the lunar lander didn't have you save your model state dictionary. So you need to look at the PyTorch documentation and learn how to save your model state. That's one of the required things for this project is to add that, and then also to submit the saved version of your model at the end of the project, and then submit it with your submission. So the next bit of advice is I think a good one is don't overcomplicate things. I can tell you when I did this project a year or so ago, I started with a much larger network and tried to do something that I thought would learn better by being more complicated. And as it turns out, that's not always the case, and this is a good example of that. The lunar lander baseline with 64 nodes per layer and 2 layers is more than sufficient. You actually could probably get it to work with something with less nodes per layer. 2 layers is good, but I wouldn't certainly recommend that you go anything more than the 64 nodes that they have in that starting baseline. A lot of students have had success adding batch normalization. It's not required, I can tell you that I've seen a lot of projects that complete without it. And it's several people have said that it has helped. I added that to my implementation when I did it, and it certainly didn't hurt. So I'd recommend you become familiar with that. It's a good technique to use in general on deep reinforcement learning. So on this simpler problem, it may not be particularly necessary, but it's again good experience and good standard practice to add batch normalization at the input of your hidden layers to keep the gradients small and having the input to every batch kind of look the same from batch to batch, so you don't have a lot of variation. And then the next thing is what you're really going to spend some time on probably is adjusting hyperparameters. I'd recommend when you make these changes to just change one at a time. Don't make a lot of changes and then try something. Work with one hyperparameter at a time, like pick learning rate. Run it with the default learning rate that you got from the baseline lunar lander. See how your project works, and then maybe modify it by increasing or decreasing learning rate in steps of a half or a tenth each time, and see what result that has. And then once you've kind of come up with a learning rate that seems to be optimal for just changing that one parameter, then start looking at other things like max T or epsilon or the epsilon decay rate. Those sorts of things are all good places to look for improvement. And the last thing, I think part of the, if you look through the lesson on this project, there's like 11 different sections there. One of those sections talks about where to get started and things to try. And one of the things is that they recommend and is, I think, really the key to success in this project. So I emphasize it here. And that is that every step you should be collecting experience, but don't learn every step. The default baseline will collect as a set of experience and then go through a learning process where the neural network will be trained using that new experience. I think you'll find that if you just put a simple check in there to only go through that training process once every 4 to 8 steps instead of every step, that you'll find much better progress on solving this environment. So again, that's recommended in the course, and it's really a key to success. It's the thing that got me over the hump on this, and I think a lot of people have found that particular step is the one that really helps a lot. So once you have a good working model and you've achieved your 13 score over a 100 episode average, it's time to prepare for submission. So you're only half done at this point, so there's still quite a bit of work to do. If you look at the item 11 on the project lesson, it talks about all the things that are required, and it's not just to get your agent to solve the environment, but there's a README file and a report to prepare as well. So make sure that you look at the rubric before you submit, and follow each of the points in the rubric. When you submit for a grade, the reviewer is going to take a look at every single one of those rubric items and verify that you have covered them sufficiently. So make sure that you run through and check those all off before you do a submission. On the README file, again, look at the rubric. It tells you all the things that are required. The two key things are really the key thing is really the dependencies. So be sure that you include instructions for downloading and installing the agents library in the Bananas environment, as well as any of the standard Python dependencies or libraries that you use. So you probably will be using, we'll be using PyTorch and NumPy and Matplotlib. So include a reference to those that they need to be installed. A really good practice is to put all those installation dependencies in a requirements.txt file so that a user can just pip that one requirements.txt file and install everything automatically. That's not required. It's just a comment here that just in general, it's a good experience to have a good practice to follow. Okay, the second half of the things to prepare in addition to your project itself is the report. And I'll have to say that if you follow the rubric and do everything in the rubric, you shouldn't have any problem with the report. But a lot of projects get rejected primarily because of one item in the rubric. The rubric says to clearly describe the learning algorithm. And I can't tell you how many projects get submitted where they basically say, I use the DQN and here's a link to the paper and that's it. And that's not what's expected here. When Udacity asks you to clearly describe the algorithm, they really want you in your own words to talk about the key features of what that algorithm is. So put a paragraph or two in your report that talks about those general features of DQN. Discuss the use of a neural network as a function approximator for the Q function. Take a look at the loss values and how they're calculated. Include a description of that mean squared error loss function and how that's used to train the DQN neural network. A key thing in this algorithm is the experience replay buffer. So write up a couple sentences again in your own words on what that experience replay buffer is and how it works. A third really key item in this algorithm is the soft update process. These are all things that Min and et al. Had come up with in getting this this baseline DQN network to work. And it was really a breakthrough in the field of deep reinforcement learning. So it's really important to understand this DQN network and all the things that's involved with it. So include a description of the soft update process, what it is and how it works. And then not really part of DQN specifically, but the epsilon greedy action selections used throughout deep reinforcement learning. It's in this baseline. You'll probably include it in your implementation. So write up a sentence or two on what that is and how it works. The final reason that papers often, and I wouldn't say often, but occasionally get rejected is that you're required to supply a rewards plot. And a lot of times that rewards plot is in your Jupyter notebook and you just submit the notebook and think you're done. But that requirement in the rubric is actually part of the report. So be sure you do a screenshot of that plot once you've made it and then include a copy of that in your report. Okay, now that you have everything done, it's time to submit your project. It's really fairly simple. Include a zip file that has your project notebook, all the other files you use like model.py, DQ and agent.py. Include your README file, include your report, and don't forget to include a copy of your state dictionary. That was one of the things you had to add to this project and include that with the submission. So you need to zip up those 4, 5, 6 things, put them in one zip file, and then you just basically send that zip file up for a grade. I would recommend, ask you please don't just take an entire folder where you've done all your work and zip up that entire folder that contains every project and every mini project you develop for the course. I can't tell you how many 100 megabyte files I've gotten to review and had to wander around through a huge library of the entire code base for everything that a student's done in this course. That's not expected, it's not required, it's not wanted. So just zip up the things that are specific to this project, not everything you've done. And then look at section 11 of the project. It has a button there to do the submission, and it'll ask you to provide that zip file for the submittal. Once you made your submission, within 8 hours or less, you should receive back a review of your work. A person like myself will review your work. It won't necessarily be me. I guess it could be. It's pretty much a random process of the reviewers that are out there that can review this particular project. And once the reviewer has looked at your code base and evaluated your implementation and looked at your README and your report, he'll go through, or she will go through every one of the rubric items and point out anything that is good or bad or missing in your project. If there's something that wasn't quite right according to the rubric, they'll ask you to take a look at those items and address them, and then resubmit it. And I have to tell you, having been a reviewer for lots of different projects for quite a while here now, our job is not to make it hard on you. Our job is not to try to make it difficult. Our job really is to make sure that you're learning things in this course, and that the rubric has some things in it that are asked of you to demonstrate your knowledge, and we want to make sure that you have demonstrated that knowledge as a demonstration that you understand this material. So please, again, look at the rubric and make sure you cover all the items, and particularly in this particular project, that description of the DQN algorithm is key. Put that in your own words, include that, and that'll go a long way towards having success on your first try. Saves everybody time if you can get through it on your first try, right? It's not just you, but also the reviewers for having to make a subsequent review of a project a second or third time. So that's really what I had to cover tonight. In summary, talked about the navigation project, starting with the lunar lander code base, making a few modifications and some minor tweaks to hyperparameters, perhaps the neural net architecture for the DQN network. And then in particular, preparing a compliant README and a good report with a description, in particular in your own words, of the algorithm that you used. Zip up all the files, submit it, and get the feedback. If you need to revise it, do the revision with a good attitude. Look at what the reviewer had to say and reply to his specific comments, and fix up the things that he said were not in compliance with the rubric, and go through the process again, we'll zip things up and resubmit. I have to tell you that it is very rare that you'll need to rerun your project. Usually if there's an issue, I mean, before you submit whether you got the plus 13 average over 100 episodes, it's pretty clear cut. Most of the issues have to do with the write-up. So don't be concerned that if you have to resubmit, having to go through and rerun the entire project. You can still submit the same sets of files that didn't have to be changed, and just update the report or the README to come in compliance with whatever was found if you had something wrong in those areas. So hopefully that gives you a good overview of the project. I wish everybody luck on a successful project. Out of the 20 students in our little group here, I think we've had 3 or 4 that have submitted and successfully completed it. The rest of you hopefully can take these ideas and work this week and hopefully get it in. So good luck to you, and we'll see you next week. Bye.